Next we can consider how to derive control words corresponding to each micro operations. So first we can consider the micro operation. R1 gives R1 minus R2. Then how to derive the control word. So here the operation is subtract operation, and source operands are, or source registers are R1 and R2, and the destination is R1 register. So this is our control word format. We have A, B, D, F, C and H fields. All these A, B, D, F and H are 3 bits and C is single bit. Then if you are considering our ALU, the A operand, or the first source operand is R1. So we need to give a 001 here, 001 code here to select R1 register, and to select R2 register we have to give a 010 binary bit pattern to these select lines. That is corresponding to A 001, and corresponding to B we have to give 010. And this ALU will perform operation, and after performing this operation, and that will reach, we have to store that back into R1 register. So for the destination we have to give 001, that is case. Then how the operation will be performed. For selecting the operation we have to give F value and C in. Based on that ALU will perform some operation, and the result will be stored into or given into shifter unit, and also this operation will update the status register. So to select subtract operation, these two columns correspond to our ALU operation or F select lines. Then this is our A minus B. For this purpose we have to give a 010 code to F lines, and C in 1, we have to make the carry input as 1. So our control word will be like this, 0101. Then here there is no shift is involved, so we have to select no shift. So this is the no shift. For that purpose we have to give 000 as the H input to the shifter. Okay. So this is the control word corresponding to the operation R1 gives R1 minus R2. Okay. Next we can consider the compare operation, that is compare R3 with R4. So in the case of compare operation, the operation performed will be subtract operation, that is R3 minus R4 will be performed, but the result will not be stored anywhere. That is the case. This will only affect the status register. Normally these compare instructions will be used just before jump instruction to make a condition. Okay. Then here so R3 minus R4 is the actual operation performed. So the source register 1 is R3 and source register 2 is R4. Okay, so here we have to give a bit pattern 011, and for this B select we have to give 100, 011 100. Then next is there is no destination. Destination has no significance. So 000 means no registers will be selected, because for R1 we have to give 001 and R7 we have to give 111. If 000 means no, the result is not stored into any one of the register. Okay. Then next is the operation performed by the ALU. Here we have to perform a subtract operation. So subtract operation, this is the table A minus B. corresponding to that we have to give 0 1 0 and the carry in is equal to 1. That is the, so 0 1 0 and the carry is equal to 1. Similarly, there is no shift is involved, so no shift, that means h is equal to 0 0 0. So this is this one is the control word corresponding to compare R3 with R4. Next we can consider the simple transfer operation. So R5 gives R4. This will perform a transfer operation. The content of the R4 will be transferred into register R5. That is transfer R4 into R5. So here the A will be this, we have to select as A input R4. So 1 0 0 will be given here, 1 0 0. Then next is destination. Here R5 is our destination. This has no significance here, so here assume that this is our destination. So for selecting a destination, in this case the destination is R5, so we need to give 1 0 1 here for the deselect lines, 1 0 1. The next is we have to simply transfer. For that purpose, what will be the F select codes? Here this one is a transfer operation and this is another transfer operation. When F is equal to 0 0 0 and carry in is equal to 0, this will perform a transfer operation and this will also reset the carry bit will become 0. And another transfer operation is if we are giving 0 1 1 to our F select lines and C in is equal to 1. In that case also transfer will take place, but transfer will but the carry flag will also be set. That is C flag, C status register bit will also become 1. So in our case we have to simply select this operation, just transfer and make the carry flag as 0. So we need to select 0 0 0 for F lines and C in is equal to 0. This is the case, 0 0 0, C in is equal to 0. And here also there is no shift operation is involved, so we need to give a 0 0 0 here. That is, this is our control word. Then we can consider another operation, another micro operation. R6 gives input, that is the input data, external input data that we have to store into register R6. Transfer input data to R6. Then here the source operand is actually input data. So to select input data here, we need to give a 0 0 0 here. That will select input data. That is the case. Then okay, simply transfer that input data into R6 register. So destination is 110. Here we have to give a 110 because to select our destination register. Then what about the operation? Here also we have to select this one, just to transfer and make the carry flag to 0. So the binary code will be 0 0 0 for F and Cn is equal to 0. So 0 0 0, Cn is equal to 0, and B has no significance here, so we can give any value to the B select lines, but for simplicity we can give just zeros, and for H select line there is no shift is involved, so we will give 0 0 0. So we will get a control word like this. And consider another operation. Our output gives R7. That means the content of the R7 is transferred and that is given to the output. That is available as output data. Transfer R7 to output. Here the source operand is R7 there is only one source operand involved, so this has no significance here. We can give anything here, but here we have to give 111, that is register R7 111. Then destination case is we have to select 000. That means if we are giving a 000 here, no registers will be selected and the output will go directly outside to external output terminals. Okay. Then what about this ALU operation code? Here what we have to give here? Here also we have to give this simple transfer, that is A, simply transfer A with C flag is equal to 0, so 0 0 0 and Cin is equal to 0. Okay, so F is equal to 0 0 0, Cin is equal to 0. That will simply transfer this whatever here to here to the shift unit. So in this case also there is no shift is involved, so we have to give a 0 0 0, that is no shift, and B has no significance, so we are simply putting 0 0 0. We can have any bit pattern here, but for simplicity we are putting 0 0 0. This is the control word corresponding to this micro operation. Then another case is clear carry bit. Here the operation is just we only need to clear the carry bit of the status register. How to perform that operation, or how to derive control word corresponding to that operation? So this will be performed by using this statement. R1 gives R1, simply transfer R1 and then C is equal to 0. So this can be achieved by using this micro operation. This micro operation, R1 gives R1 and C is equal to 0. So here if you are looking into this function table, this operation actually do that one. If you are giving a 0 0 0 to the F input with the carry in is equal to 0, that will simply transfer a register to output of the ALU and carry flag will be set. So that is used in this case. But here what we are doing is we are simply transferring R1 to R1 itself. So the R1 content will not change, but the carry flag will change. Carry flag will become reset. So here the source operand is, source register is 001 and destination is also 001. That is 001. Here also 001. B has no significance here. Then function is 0000. This will simply transfer the content of R1 to R1. So the R1 content that has no change, but this will change the carry flag into 0. That was our A. Here also there is no shift is involved, so simply put 000 for this H field and also B field. Okay. And another operation is micro operation. R3 gives shift left R3. Shift left R3 with IL is equal to 0. This is the case. SHL R3 meaning is shift left R3 with IL is equal to 0. So here shift left R3 with IL is equal to 0. How to derive control word corresponding to this one? So actually this one is the operation shift left right is this one with IR is equal to 0. This is the 0 0 1. For H input we have to give this one. And how to achieve this is we can simply transfer. First we need to simply transfer the register content to the output of the ALU. Then only we can perform the shift operation. Okay, because here shifter is here. So first we need to transfer the register content through the ALU to the shifter. Then we will perform the shift operation by giving the corresponding H values, H inputs. So we have studied different transfer operations. One is this one. This is one transfer operation, and this is another transfer operation to simply transfer register content to the output lines of ALU. But here the problem is if you are performing a transfer operation, then that will affect the carry flag also. In this case, this will make the carry flag into 0 in the status register. This will also change the carry flag into 1 in the status register. So we need to perform a transfer operation that will not affect the status register. For that purpose, we can use the logic operation, this OR operation. What we have to give is use the same register on both sides. Then what will be the output? A or B? If we are performing A or A, what will be output? That will be A itself. So that can be used here. First perform R3 is equal to R3 or R3. What will happen? Then the output of the ALU will be R3 itself. That will simply transfer the R3 from here to here. And in the case of a logic operation, that will not affect status register. So we will get R3 here. Then we can perform the shift operation by giving the H select lines. Okay. Then what will be the fields in our control word? So our source is source 1 and source 2. They are 3 3 R3. Here we have to give 3. Here we have to 3. So the R3 will be selected as this 2. Then perform OR operation, logic OR operation. Okay, and destination is also register R3. That is this case. Then logic OR operation. This one is the logic OR operation. The corresponding code is 100. We have to give a 100 to the F. And this carry in has no significance here. That is actually a don't care. So F we have given 100 to F. Then carry in we simply put 0. We can give any value there. That has no significance here in the case of a logic operation. Then what about the H field? Here we have to give shift left R3 with IL is equal to 0. So shift left. Okay, shift left IL is equal to 0. This to be selected. The 0 1 0 corresponding H we have to give 0 1 0 to H input. So 0 1 0. So this is the control word corresponding to R3 gives SHL R3. Okay. Next we can consider R1 gives CRC R1. Circulate right R1 with carry. So in this case also first we need to transfer R1 to the output of ALU. For that purpose we can perform a logical OR operation. That is R1 gives R1 or R1. So the corresponding pattern will be like this: 0 0 1 0 0 1 0 0 1. That is here 0 0 1 0 0 1 and destination is also 0 0 1. Then for logic OR operation 1 0 0. This is logic OR operation 1 0 0 given Cin is equal to 0 because that has no significance in logic operations. Then next is circulate right R1 with the carry. So now the R1 register is available as input to the shifter. So what we have to give it to the H input. For that, circulate write with carry. This is the operation. So the corresponding value is 101 has to be given into H input. So 101. So this is the control word. And we can consider R2 is equal to 0, that is clear a register, simply clearing a register. So how to derive control word? So the destination is R2, so 0 1 0 here, that is here we have to give a 0 1 0 destination select. Then how to perform clear R2? For that purpose, we can just consider our shift unit. This is not our complete diagram, but simply we can understand this. So there is a 0 input is tied to all the muxes or shift. The internal structure of is actually a collection of muxes. This is tied. So when we are giving a 1 1 here, what will happen? These zeros will be selected and that will be available through the output of the shift unit, irrespective of the ALU output. These are the output from ALU. Whatever the value here, that will not affect this, that will not be available here. The value available will be simply these zeros will be selected and that will be available irrespective of the value given here. Okay. So that operation is this one, zeros to output bus. When 0 1 1, if we are giving a 0 1 1 to H input, then zeros will be available through the output of the shift unit irrespective of the output of the ALU. So in this case we have to simply specify the destination register and H input. All other are don't case. So here D input, D field and H field. Here we are giving 0 1 0 because R2 register and this H 0 1 1. Then whatever the operation performed or values here, simply zeros will be available here and that 0 will be copied into the register specified through this D select lines. Yes, in our case that will be stored into register R2. So this is the clearing a register. So we are simply putting zeros in all other fields. Okay. So we'll get a control word like this. So similarly we can obtain all other micro operations or we can derive control words corresponding to all other micro operations. Okay, thank you.